Welcome to this video. We'll start talking about text analytics. Text analytics is a subset of techniques used to process text written in a human language, also called a natural language, for the purpose of drawing insights. Now, to give you the big picture, we will only be looking at a really small subset of these techniques. There is a wide range of algorithms, tools, and techniques commonly referred to as natural language processing or computational linguistics that really aim at not only processing text but generating text and creating smart computer algorithms that can converse with human users. We're only drawing from a subset of these techniques for the purpose of analytics or text mining as well. Now, this is an important topic for many reasons. Obviously, we all now recognize that we are interacting with our devices using natural languages. So we talk to our digital assistants, they talk back to us. But really, the bulk of information and data released on the internet is unstructured, meaning it doesn't fall in a two-dimensional table. And text is just one example of unstructured data. And this is increasingly common if you think about data you generate on the internet. Obviously, there is trace data. Whenever you use your device, there is a trace left behind. But there's also all of the content that you and other users generate on social media. If you think about, companies, all of the records and emails and conversations, all of this data is unstructured in the form of text. So it becomes important to integrate text analytics within any data analytics pipeline. This is not an easy task. And it's not an easy task because human language, in contrast to a programming language, is ambiguous. Let's take a look at this example. Take a look at this sentence. Time flows like an arrow. What does it mean? You can pause for a second and think about it. Obviously, the sentence is widely understood as time passes quickly. But that's not the only meaning of the sentence. Indeed, the sentence has two more meanings, probably two more main meanings, such as this one: time flies like an arrow, fruit flies like a banana. So this is supposed to be a joke, but this illustrates the point that the sentence that doesn't look ambiguous to a human agent is ambiguous because different words in this sentence can mean different things. So for instance, if you think about the common meaning of the sentence, flies is a noun. In this meaning, time flies like an arrow, flies is a verb. The third meaning of the sentence makes time a verb, meaning time flies like an arrow. So you have a stopwatch and you're trying to time the flies like an arrow, which is an absurd meaning, but syntactically speaking, it's a perfectly fine way of looking at this sentence. So ambiguity is the core of human language, and ambiguity is usually resolved with experience. Experienced speakers of the language will understand the meaning, but that only comes with experience. Many of the processing algorithms and technique rely on statistical methods and machine learning to substitute for this experience. We're not going to look at the details of how these techniques and algorithms kind of work, but you have to understand that many of these techniques relies on models which are trained with some form of labeled data. So here is a way to think about language. If you have a human language text, you can think about this text as having multiple dimensions, and each one of these dimensions look kind of built on top of each other. So we have morphology and lexicography, and those have to do with the structure of the words and the structure of the subwords in the case of morphology. The second level is syntax, which basically the structure of words in the syntax. For instance, in the previous example, when I was talking about time flies like an arrow, this was a debate about the syntax of the sentence. what's the role of each word, which words are nouns and which words are verb. But obviously you can take a look at the word itself, and this gets us to the lexicography of each individual word. So one can look at flies and recognize that flies is a verb in this example here, and that verb has a stem, which is fly, it has a tense, and so on and so forth. Once we go beyond syntax, we hit the semantics, which is basically the meaning. And obviously it's kind of related to syntax. The different roles that the words play in that syntax determine the semantics, the meaning of the sentence. Whether time was a noun or a verb, flies is a noun or a verb, determine the semantics of the sentence. But that's not a one-to-one mapping. You can have perfectly unambiguous syntax, but the meaning of the sentence here can be completely difficult to figure out. Until recently, semantics used to be one of the more challenging problems in natural language processing. Now today, with advanced machine learning, artificial intelligence, and increased access to large-scale datasets, this problem is becoming more and more resolved. But we can sense it every time we speak to our digital assistant, smart agents. They struggle when it comes to semantics. This is just a subset of the spectrum. People also talk about the pragmatics, which is one level beyond semantics, which basically refers to the purpose of the syntax of the sentence or the text. For instance, you go checking in a store and the cashier will ask you, "How are you?" Now, "how are you" is not ambiguous. It basically, strictly speaking, probing about the welfare of the person. But that's not the pragmatics of the syntax of the sentence. The pragmatics of the sentence is kind of like an icebreaker of the conversation. Similarly, when people talk about the weather itself is not important here. It's kind of a starter of the conversation. That's the pragmatics of the text. So try asking Siri or Alexa about the weather, and they will not get the pragmatics of the sentence, but they may get the semantics at this stage. So we will be kind of mostly looking at the level of syntax and a bit kind of scratching the level of the semantics when we look at the different tools and techniques in the text analytics processing workflow. So in this workflow, we will start with raw text, which is basically string. Now again, our goal is to gain some insights, so maybe some relations about different constituents of that text, maybe some summary of what the text is about. When we have this raw string, there are different stages in this workflow. It starts from sentence segmentation, which is basically breaking the text into sentences. Next, we take each sentence and we break it to different words. They're also called tokens, and this step is called tokenization. In each one of the words, if we want to know the role of the word in the sentence, whether it's a noun or a verb, we use a technique called part-of-speech tagging. Now, beyond knowing the role of the word in the sentence, if we want to know the conceptual category that each word belongs to, some words have conceptual categories such as proper nouns, places, products, services, company names. This step is called entity detection or entity extraction. Once we do that, we can extract some relationships between these entities. And this is useful because many of the analytics kind of processing tasks boil down to understanding some relationships. So I want to understand, for instance, relationships between, contracts, clients, and geographic area, for instance. These kind of relationships can be extracted once we have entities, and when we have entities, we can employ some form of kind of correlation to detect relationships between these entities. Obviously, this is one workflow, and those are selected 5 essential steps in the pipeline, and there are more. As I said, this is such a broad field, and there is always something new, and we can't do it justice in 2 lectures. But the purpose of this lecture is to basically focus on these basics. No matter what you do, you'll need to go through sentence segmentation, tokenization, part-of-speech tagging, and somehow entity detection.